Okay, great. We've still got a few people filtering in, but we'll make a start with the presentation. So, um, welcome to today's webinar on Microsoft Fabric. My name's Ben Jarvis. I'm CTO at Adatis. In terms of the agenda for today's session, I'll be kicking off with a quick overview of what Microsoft Fabric is and just where we see it fitting into the future of analytics. Then I'll pass over to Karina, who's one of our senior consultants, to talk about potential migration pathways for when moving workloads into Microsoft Fabric. And then finally, we'll hand over to Dan Billsborough, who's another one of our senior consultants, to give a demo of the Fabric platform. And then if we've got some time at the end, we're finished with some Q&A. So as we're going through the session, feel free to put your questions in the chat and we'll pick those up at the end. So I'll kick off with my first few slides. So just to recap, over recent years, we've seen an evolution in data platform architectures. So initially we started with your typical on-prem data warehouse where you take structured data, do some ETL on it, and load that data into a relational data warehouse for reporting and analytics. And then data scientists came along and they needed access to data to begin building out machine learning models. And this required access to structured, semi-structured, and unstructured data. So we needed a way to store a variety of different data types that fall outside of your typical structured data that comes from your transactional systems. So in order to enable this, we created the concept of a data lake. And that basically gave us a central place to store data and make use of it in analytics and data science. And this allowed data scientists to start using their own tool sets. So maybe they were more comfortable in Python or languages such as R, and they could work in those tools on top of the data lake. But the problem was that our data engineers would continue using relational data warehouses to build out their data assets and build out data warehouses. So we effectively ended up creating two separate environments, one for data engineers and another for data scientists. And this effectively created silos of data. So it made it really difficult to share data sets between the two and made it difficult for data scientists to start to use some of those curated data sets in their analysis. And then a few years ago, Databricks came along with the solution, which they call the data lakehouse. And effectively with this approach, we still have our centralized data lake, so we can still ingest structured, semi-structured and unstructured data. But Databricks advocated the use of open and accessible file formats, such as the Databricks Delta format. So our data engineers can build out their assets in the data lake, and then our data scientists and other users can make use of those assets using whichever toolset they're most comfortable in. And because we're using open file formats, we're not tied to a particular compute engine. So we could have analysts that are working within SQL, and we might have data scientists who are working in something like Spark. And all of those different personas can collaborate on top of the same set of data, but using the tools that are most suitable for the job that they're trying to do. And one of the problems in more recent times is that to build up a solution like that was effectively like building Lego. So in Azure, you've got lots of different services. So they're our Lego bricks, and each of those services has different uses and has different attributes and slots together in different ways. And we want to build ourselves a nice lake house. So to do that, we need to take a combination of those services and work out how to slot them together in the right way to build out a platform that's scalable and suitable for our current and future needs. And to do this, we'd have to bring together lots of different components. So you could have something like Databricks, you could have tools like Data Factory, you might have some SQL databases, you might have some key vaults. There's lots of different Azure services that we're bringing together to build out those capabilities. And that brings a lot of complexity with it in terms of integrating all of those services together. And it also means that each of those different personas would have to work in a different tool set. So you might have your data engineers that are working in Databricks and your data scientists that are working in Databricks. But then you might have analysts who are working in Synapse or Power BI. So people would be hopping between different tools and you'd have to manage security across those tools and make sure they can all talk to each other. So it becomes quite difficult to manage and takes a lot of work to get that platform right and get that platform working in the way you want to. So Microsoft's solution to this problem is Microsoft Fabric. And effectively what they're aiming to do with Fabric is bring all of those tools that we're used to using. So things like Power BI, Data Factory, Spark for data engineering and data science, SQL for data warehousing, and all of those other tool sets that data engineers, data scientists, and data analysts really like to use. And their aim is to bring all of that together into a centralized SaaS platform. So rather than us having to manage that infrastructure ourselves and spin up our own Azure services, all of that is pulled together into a single SaaS platform with a lot of that management overhead taken away from us, and a lot of that worry around how to configure those resources is now put onto Microsoft. This is all underpinned by something that's called OneLake, and that's basically a centralized SaaS data lake. So rather than us having to spin up storage accounts to store all of our data, we have a SaaS equivalent of a data lake storage account within the Fabric platform. And that gives us a centralized place to store all of our data and allows us to apply governance centrally as well, and gives us that unified governance layer on top. So we can make sure that people that are making use of that data have the right guardrails in place around access, and we can ensure that all of that data is catalogued and classified as required. So some of the key benefits of the Fabric platform are, it's obviously a SaaS platform. So as I said, we don't need to worry about managing any of that infrastructure. You know, it's kind of, you switch it on and you're able to get started really quickly and start delivering value and ingesting data. It simplifies collaboration and self-service. So rather than people having to hop between different tools and us having to manage access control in different tools, we've got all of those tools under one roof as part of the Fabric platform, and we can manage all of that centrally and simplify that self-service process massively. We've got the central governed and open data lake. So as I said, OneLake is that data lake storage layer that underpins the whole platform. And that allows us to store all of our data centrally and allows us to apply the right governance on top. But it's also making use of open file formats like the Delta format. And that means that we can switch out the compute layers that are on top of that data, and means that we've got all of that data in an open format, so we're not tied to any proprietary compute engines. There's also close-knit Power Platform integration. So a lot of clients we see are using tools such as Dynamics 365. And one of the problems previously is that you'd have a nice SaaS platform in Dynamics 365, but then if you want to do any analytics on that data, you'd have to start spinning resources up in Azure. With Fabric, there's really close Power Platform integration, so we can lift that data from Dynamics into Fabric, and then we can build the analytics on top, all staying within that SaaS environment and removing the need to spin up any resources in Azure. We've got centralized cost management. So one problem we see with a lot of clients is having to manage Azure costs and having the ability to apportion those costs between different business areas. Fabric makes that really easy, and there's the concept of workspaces that you'll have seen in Power BI, and we can manage the costs at the workspace level and see how much each workspace is consuming. There's also support for low code and pro developers. So our pro developers are generally working in tools such as SQL or Python. And we might have some people within the business that want to actually start building out their own data pipelines and get into grips with some of the data themselves and prototyping models. Previously, we'd have to hop between different tools to support that and give the developers the experience they want, but also give the business access to those tools, but applying the right governance to allow them to do that. With Fabric, we've got all of those tools such as Spark and SQL, and they're set up in a nice environment for developers to work in. But then we've also got tools such as data flows that allow our low-code developers to actually get to grips with the data and build out their own pipelines. And then finally, all of this really means that we can focus on delivering business value rather than platform engineering. So rather than us having to make sure we've got that platform stood up, make sure we've got the right infrastructure in place, and make sure all of that infrastructure is hardened and able to cope with the workloads we're planning to throw at it. All of that is handled now by the Fabric platform, and that means that we can focus on delivering business value and focus on getting data through the pipelines and delivering something that the business can actually start using. So some of the really key features that set Fabric apart from other platforms are, the first one is shortcuts and mirroring. And that effectively means that we can bring data from other systems such as Dataverse, SQL, or other cloud providers such as Amazon S3 into the OneLake platform without needing to do any kind of ETL. So this means that data is available under the OneLake banner, and it's a very simple operation to make that data available. So we don't need to build out any pipelines or build out any processes to move that data across. The shortcuts and mirroring basically allow us to mirror that data within OneLake and give us instant access to it. The other really key feature is the compute and storage separation. So as I mentioned, the Fabric is based on the open source Delta format and uses that within its storage layer. And that means that we can swap out compute tools and use languages such as Spark or SQL or Custo on top of our data without needing to move it from one place to another to enable that. So everything sits within OneLake and is in Delta format, and then we can switch out the compute engines that sit on top of that. And then finally, following on from that, the final key feature is the Power BI Direct Lake connectivity. And that basically means that we can put Power BI directly on top of the data lake rather than using import mode. And that means that we don't need to worry about Power BI model sizes or getting data into our Power BI model or refreshing those models. We can put Power BI directly on top of the data lake and get similar performance to import mode without the need to store that data in memory. So one of the key questions we get asked is how much does Fabric cost? And there's a couple of different options, and both of them are charged based on your individual usage of each service. And effectively, the way it works is each service burns a different portion of your overall capacity. But in terms of paying for that, there's two different options. The first is to use your existing Power BI Premium SKU. So if you've already got Power BI Premium, then you get access to all of the features of Fabric by default. And the services will consume your capacity within Fabric in the same way as Power BI usage would. So if you've already got that premium capacity and maybe it's not being fully utilized, then Fabric is a good way to start using that and start building out some workloads on top of it. The second option is to use a Fabric SKU, and these are a build for Azure. So you purchase them through the Azure portal, and they're charged by the minute. And these capacities can be paused or resumed based on your usage. So say we're running an ETL overnight, we can run our Fabric capacity during that ETL window and then pause it again once that ETL is finished. So that means that we're only charged for what we use, and they can be quite a cost-effective way of running a workload in Fabric. They start at £241 per month for the F2 SKU and go up to some huge amounts. It's difficult to know without looking at a specific workload how we'd need to size it. But generally the F2 SKUs, so the smaller SKU, works out quite cost effective for sort of smaller data volumes or your typical sort of transactional volumes that are within the millions of rows region. There's also a 60-day free trial, which is available for you to test out the capabilities if you're looking to experiment with Fabric and understand how it works. So just following on from this, at Adatis, we've got a standard approach that we use to deploying Fabric. So we basically take all of those underlying tools that are provided by Microsoft, and then we apply a couple of accelerators on top of that to help us speed up the process of adopting Fabric. One of those is our orchestration service, which helps to manage processes within the platform. And that helps us manage which jobs are going to run and the dependencies between those different jobs in the platform. and handles things like error handling if a job fails and things like that. So they're kind of quality of life improvements for your developers that make it easy to get started on Fabric and build out production workloads. We've also got our code generation tools, and they basically allow you to auto-generate Spark code for ETL processing. So they handle a lot of your typical data warehousing type workloads and make it really easy to start delivering data warehouses on top of the platform. We've also got a standard reference architecture, which Dan will run through in the demo. And this is based on your standard medallion architecture that's quite typical with data lake houses. And effectively, that involves us using Data Factory to ingest data into the raw area of the data lake. And that's basically a copy of the data as it was at source. We then use Spark to transform, to do some cleansing and validation on that data and begin to standardize the format of it. And then we again use Spark to build out our curated models, and they will typically be a dimensional model for reporting, which gives your users the ability to slice and dice data and gives them the ability to start to actually get some insights from that data. And that data is then served up for a lakehouse in Fabric, and that gives you the option of using Power BI through Direct Lake or using tools such as SQL to query that data as well. So it's quite a simple and flexible architecture to start delivering some value from Fabric. So Fabric only came into general availability a few weeks ago. So there's still some gaps in functionality versus some of the more mature tools that are out there, such as Synapse and Databricks. Some of the key features that we see as missing are private endpoint support, which is due in 2024. Fine-grained security within the OneLake data lake. So that would allow you to restrict access at the folder or table level to specific Azure AD groups. And that's due to go into public preview in Q2 next year. Then there's Lakehouse schema support, which again is 2024. There's Git integration for Data Factory pipelines, which is due in Q1 next year. And Data Factory connection parameterization, which again is due in Q1 next year. And these are some of the key things that we kind of see as missing based on our experience of Fabric so far. For some clients, these won't cause an issue, but for other clients, they might cause issues. Say you're working in a more regulated industry. So one of the key questions we get is whether Fabric is actually ready to use in production. And the answer, which probably isn't of much use to some people, is it depends. So really, it depends on the kind of workload you're running and depends on your specific requirements. So say something like private endpoints are essential for you, then we wouldn't recommend going down the Fabric route. But say you've got some appetite for risk and you're happy to work with a product that might not be fully mature yet, then we definitely recommend going down the Fabric route and at least start to build out some POCs and start to use the tool and skill yourself up on it. So I'll now pass over to Karina to talk through some of the migration paths on Fabric and talk through how you can take existing workloads and move them up to the platform.
Hi, thanks, Ben. Yes, yeah, get control. Okay, so Microsoft have made Fabric to be dynamic and versatile. So what do I mean by this? Well, they've made it so that you can integrate Fabric in different ways at different times. Here at Adatus, we've been building and developing to see the options and give our opinions on the best ways to migrate Fabric with the following technologies and tools. So using Fabric in this adaptable way allows the consumer to be able to migrate to Fabric at their own pace and without the need to rewrite all the current existing code. In some cases, the migration will be a lift and shift, but in other cases, there will be the need to re-engineer the workload. Microsoft have been working on this and have made significant progress since the initial drop of Fabric and are continuing to do so. There are multiple blogs on our website which go into the details of each technology when you're migrating to Fabric. There's a really good one on Synapse by a colleague of mine called Will, where he goes into the details of some of the changes you have to make on the workload to get it to be able to work in production as you would expect. One of the main differences between Fabric and Azure is the data storage. As Ben touched on, Fabric doesn't have a dedicated SQL pool or relational storage. Instead, it uses a warehouse data, which is persisted in the data lake format within one lake. When looking at migrating to Fabric, we need to access the workloads first, considering some of the following items: what type of workload you have, the source system types, the type of data being processed, current implementation, etc. Once all of that data has been collected, we can then start to understand which migration pathway would be the most beneficial. As you can see on the slide shown, we've grouped technologies together and suggested our migration paths into Fabric based on what we've learned, what we found, and the most common structures and scenarios that we've come across. We've grouped them into 5 paths, but using 3 different types of solutions. Okay, so on-prem application and Azure Synapse dedicated. We would suggest using Fabric with the data warehouse as storage. The on-prem appliance, Synapse dedicated and on-prem apps would use Fabric with then the data warehouse migration path on the side. The ability to mount existing pipelines from ADF and Synapse into Fabric, there's no need to change or build from the ground up. There are longer term plans as well, as Ben mentioned, to upgrade paths to turn the pipelines into native pipelines and to use parameterization within the ADF. So Databricks, stay put. You can use Fabric for serving, but you can connect to the lake with Databricks and are able to read and write, allowing you to use Databricks as you currently are, with the addition of your architect being within the Fabric service. The use of this is the same as what is currently done within the cloud structure. You connect a Databricks workspace to the lake and the path structure you need. Perfect. For on-prem and Azure, including Synapse Spark and serverless SQL, we have recommended the business analytics reference architecture, which you've just seen Ben discuss, and Dan will be demonstrating for you after this. Why do we recommend this migration path? Well, on-prem, Fabric, with its unification of data store and standardization on data lake, allows you to eliminate multiple current issues with the on-prem, such as data duplication and silos. Fabric has made it easy to connect to on-premise data sources as well as cloud, allowing the option to keep on-prem services if required. You can perform your ETL or ELT on Fabric with the Lakehouse architecture end-to-end, using data sources, integration, transformation, and store, and consume, making it an end-to-end process. You're able to keep the overall architecture the same and minimize the code changes when you replace the cloud deployment with a service Fabric application. It allows you to migrate slowly and in phases if required, and keeping a BAU setup while making the necessary changes. You're able to continue your work day to day, BAU, taking phases, taking chunks, migrating slowly and as much as you need or as little as you need. The Azure Spark serverless side, Fabric's Lakehouse and Data Warehouse and serverless SQL all share the same engine at their core. Fabric uses Delta Lake at its core, and there are a few routes you can take to convert your data if you're not already using a data lake. Using Spark jobs or notebooks, you can read the Parquet data and then write the data frame to the data lake table. Fabric allows you to support this. And they are moving, Microsoft are building constantly, they're improving, they're taking on all of the feedback that people are giving them, and they're improving it on a day-to-day basis at the moment. So that's my whistle-stop tour of the migration paths and which ones we've recommended from what we found and been playing around with Fabric for a while and pulling it into production. And I think that slides in nicely to Dan's demo on the business analytics reference architecture. Over to you, Dan.
Thanks, Karina. Share my screen. Cool. I hope you guys can see my screen. Cool. So yeah, I'll be following the architecture that Ben and Karina have already talked about, the sort of reference architecture. And what we'll be doing is really just a quite a simple end-to-end demo of kind of a source data all the way through to modeling, reporting, and then data activator, which I'll get onto at the end. So to start, where we are at the minute is we're in a data pipeline, basically. And as you can see, I've kept this one really simple because all we're doing at this point, as Ben talked about, is we're trying to get it from source to that raw or bronze layer. So there's no data manipulation or aggregation or filtering or anything like that, not even cleansing the data at this point. We're essentially just moving it to the one lake. So all we really need for that is this copy activity. I've just set up a very simple blob storage account. You give it the file path, etc. And then you choose a destination. So I've chosen to send it to the lakehouse and then specified this raw folder. That's where I want to send it to. Again, if you're used to sort of the data factory experience, you get this whole host of activities. You could set up much more advanced logging than this. You could maybe call an Azure function. I just created a very simple one to say, when it fails, send an email, basically. So once that's all set up and the data has basically been copied from your source, wherever that is, to your lakehouse, then we get to this point. As you can see, we've got our lakehouse product, I've called it. I've just used some very simple product data here. And you see, yeah, the raw folder with our product file in it. Now, the next thing we need to do with that is, like I say, that's just a copy of the source data. It's not going to be cleansed. It's not really appropriate for business users at this point because the data basically might not be good quality. So that's when we progress to the next stage, which is this. This is, again, fitting in with the architecture, using a Spark notebook to cleanse the data, validate it a little bit, and get it to a point where actually it could potentially be kind of used and reported on, really. So just to kind of run through this a little bit, I won't go sort of line by line, but essentially what we're doing here is we're reading the data from that file, and we're specifying a schema. So we're just saying, like, these are the column names in the file, giving it some data types. So just some very basic validation. And then we've got this line here, which is what actually kind of reads it in. So we read it into a Spark data frame. You give it you say, I want to use this schema, essentially, this one we've defined here. And we give it this file path. So again, you can see at the end here, that's where our file was that we saw a second ago. That's where we're reading it from. And then just displaying the data, check it's all coming in fine and looking good. Then you can get on to some data cleansing and validation. You can see here I've used a really simple example. I'm just saying, if in the product ID column it's null, then get rid of it, basically. But you could obviously add to this. You could add sort of like lineage columns, things like that. You could maybe, if you've got spaces or in the data, maybe you want to trim them. Perhaps you want to change hyphens to underscores, all those sorts of things. This would kind of be an appropriate place to do it. And then we are essentially writing that data out. So at this point, it's kind of all been cleansed, validated, and we're writing that data out into a Delta table. So you can see that here, that I've got this table here. That's the output of this, essentially in a sort of more cleansed and data typed format. From there, where we want to go is that's all good in terms of it's sort of validated and cleansed, but it's not really appropriate fully to be reported on because it's not been modeled. It wouldn't be very user friendly. So that's when this next stage comes in. This is essentially getting it from base to curated or silver to gold, whatever kind of whatever you'd like to call it, really. And this is where it should already be cleansed, but actually we're implementing business rules. So if I give a very simple example of that, with this product data, for example, you get like an original amount, you get a discount, like maybe 40% off, 30% off, those sorts of things. But what we didn't get is actually a discounted amount itself. So I'm just very simply deriving that by saying, taking the original amount, if it has a certain percentage off, then taking that amount and kind of minusing it from the original price to just derive that column. So these are the sort of examples we mean by sort of business logic and rules and being able to, and this is the place really to implement those. And obviously the Spark notebooks, because you can use PySpark or SQL like I'm doing here. It gives you all the flexibility you could want, really. I'm then also joining it to a couple of other tables, a couple of other dimensions. So really this table here, this is our facts table. So this will store the sort of amounts. And then I'm creating a 2 dimensions for brand and product. So we'll be able to essentially filter the amounts by product or by brand type, for example. And then again, just some very simple auditing. I'm just adding on a created date time, but again, you can kind of go as far as you want with this. Perhaps a column to uniquely identify each row if you needed to trace it back, for example, and really as much or as little as you wanted at this point. Perhaps some logic to handle how you'd merge the new data in, all things like that. This would be the appropriate place for it. And then similar to the previous notebook, we're just then essentially outputting that data to a particular location in the Delta format, and then just cleaning up these resources at the end that we've created in this notebook. So at that point, you'll essentially have some model data. As you can see, these tables here. This is the output where it's been modeled, it's been cleansed, and it should be sort of ready for reporting for business users and to create reports from. So the next step is this one. What you get with each lakehouse is a default data set. So it will look at the tables and it will automatically create a data set for you. You can then edit it and make relationships from it, like I am here. So you can see that we've got this model tab here. You can see these are the 3 tables that we saw a moment ago, but we're now in an environment where we can join these together. We can add measures and calculations and things like that, and create this sort of semantic model that you're used to if you used Power BI before, to get it ready for reporting, but without having to sort of manage it separately. It's kind of already done for you in a default state, and then you can edit it to how you want. So you can see I've just joined the tables here together, and then we can start creating reports from this. So if I just show a very simple report, so you can see just product sales overview, a couple of filters, simple table of data, and a couple of tiles with those measures on the total amount and the total discounted amount. And obviously you can filter in the way you'd expect. You could click on particular brands and it would filter those particular things. So that's sort of, I suppose, fairly standard up until this point. We've got a data set with some reporting on it. But the bit I wanted to talk about next, which I think is a massive benefit of Fabric, is data activator. And really what that is that's an experience within Fabric that allows you to go from not just sort of passive reporting and kind of checking the numbers, but actually, how do I get that report and how do I take action on it? So let me show you what that looks like. You could, for example, if we've got this tile here where it's got a total discounted amount, you can click on these 3 dots and you can say set alert. And this is where you can then set up that condition. So for this particular measure, so equals 0.58 billion, maybe I could say once it equals 0.6 billion, then send someone an email. Maybe that example isn't the most accurate, but if we take an example such as if we think about double entry bookkeeping or accounting, whereby your sort of debits and credits, at least in a simple sense, should always match up. Maybe there's a finance report where you could have a calculation which balances out the debits and credits. And if it doesn't equal 0, for example, if that measure doesn't equal 0, then you could send an email to a finance manager to take a look. So that's maybe a use case of where you'd want to use that sort of going from not just reporting, but actually, getting a notification and taking some action on that. Now we can go a fair bit further than that. Actually, that's a fairly simple example where it's just a notification. But what if you actually wanted to really do something more than that? That's where an event stream comes in. Now, what an event stream is again, it's a service within Fabric, which would allow you to essentially, as you can see here, take a sample, some source data essentially, and then push it to a destination in real time. So this is basically a way to have a no-code experience to interact with real-time data. So what I'm doing here is I'm taking just a sample data set in this case, and then I'm pushing it to something called a reflex. So you'll see this type here says reflex, and what a reflex is if I show you, a reflex again is a Fabric item that allows you to kind of handle that scenario in terms of taking an input of data, having a condition in the data, and if that condition's met, taking an action on it. It's the sort of container for that essentially. So as you can see here, we've got our event or our event stream. That's essentially our data source in this case. It's the data that's coming into this reflex to then be able to compare it against a particular condition. If we then go to triggers, you'll be able to see that I've selected a particular column from that data. So that data was just sample data, I think, for just taxi data. So there'd be a fair amount. So I've just selected from here that from the data coming in, I wanted the fair amount column to just see how much people are paying for their taxi fares, essentially. You then get down to this part, which is the conditional logic. I've just selected, for example, where it's greater than 50. Each time it's greater than 50, then take particular action. But there's tons of options here in terms of all these sort of operators you probably expect. Maybe if something becomes true or false, if something changes, for example, you can then set that as the sort of condition as well. And again, with the actions, you can do what we saw in the Power BI report, which is either send an email or a Teams message, but then there's also this custom action option. Now, to have that, we need to create a custom action. That's why it's blurred, because we haven't created one. So if I create one, it will bring up this little pop-up where you just specify a name and some input fields, and then you get this connection string. Now, if we were to copy that connection string, what we'd get is we'd click OK on that, and then we'd open up Power Automate. You can then come into here and give it that connection string. And then at that point, what it will do is you're essentially saying, once all this has happened, taking this data, once this condition is met, take this particular action. And that action will be done every time that condition is met. So this will be triggered. This Power Automate will be triggered. In this example, I'm just saying send an email. But as you can see, when I click on here, there's a whole bunch of different activities you could do. So maybe you could grab some data from Excel, update your dynamics. There's a loads of different applications where you can take all sorts of actions on it. Obviously integrates very well with already existing Azure services. And so that's really how you can go all the way from ingesting data to a report, and then further than that, actually, setting some conditions and thresholds and things like that, whereby when they're met, you could then an action would be taken automatically for you. So that's Data Activator really in the kind of whole process. I just wanted to speak about, I'll just share this. I just wanted to very briefly speak about Power BI and Fabric really. So what if you've already got Power BI? What does it kind of mean? Do you have to change anything? Should you be concerned? Anything like that? And really, I think largely it's good news, because actually Fabric is sort of integrated into Power BI, or they're certainly integrated together. I think that's certainly good news in terms of what Microsoft's vision is going forward in terms of making this all closer together. I think in any case, it certainly is, there's no need to do anything, especially if you don't want to. There's no need to be thinking about, oh, do I need to move this from here to there? Do I need to change the type of something? There's really not much that's necessarily needed, but I do think there's big benefits to going to Fabric. I think the main one, which Ben called out earlier, is this direct lake connectivity, which, as Ben pointed out, sort of gives the advantage of import mode in terms of performance, but then also the advantage in terms of direct query in the sense of you don't have to store that data and refresh it and things like that really. So I think that's quite a Power BI sort of explicit feature that I think is a big benefit of going to Fabric. I think the other couple of ones are what I just showed there, which is Data Activator, which is in preview at the minute, but I'm sure will be coming soon, whereby you can go from reporting to actually taking action on that data, either in real time or from a Power BI report. And I think the last one, which again I think would be a reason to maybe consider moving from Power BI to Fabric, or certainly trying it out, is with the One Lake, as Ben talked about, that kind of unified experience. It should enable better self-service. So where you might have Power BI users at the minute who have got some reports, but then they maybe want to bring in more data, don't know where the data lives, that sort of thing. With the One Lake, it should make that all a little bit easier in terms of basically, allowing users to access that data and bring it into their reports, and just enabling a better self-service experience overall. Cool, that's really what I wanted to talk through today, and I'll just hand it back to Ben now to talk about some next steps, I think.
Sure, thanks, Dan. I'll just share the deck from my side again.
Sure.
Okay, great. So in terms of next steps, so obviously at Adatis, we've been doing lots of R&D around Fabric and beginning to use it with some customers as well. So if you're interested in finding out more, we've got a 1-hour briefing call that we can offer for free, just to give you an overview of Fabric, understand where it fits into your architecture and where it could potentially fit into your current data strategy. We're also able to offer a proof of concept using the Fabric platform. So the idea of that is for us to come in, get Fabric spun up, and begin getting some data ingested and begin delivering some business value from the platform. So if you're interested in either of those options, then please feel free to get in contact with us after the session, and we can get something arranged. That's all we had scheduled for today. So we've got some time for Q&A now. So I know we've got some questions to get us started, but if you've got any other questions, then feel free to put them in the chat and we'll be able to answer them between us.